leading coefficient and the... Good. Good. Who is our leading coefficient? Well, that's kind of easy for that guy, right? But what's the struggle about our constant term? Who goes into 60? Well, 1 and 2 and 3 and 4 and 5 and 6 and... 6 and... Oh, 8 goes in too? No, 8 doesn't go in. Oh, careful. 6 goes in 10 times. There we go. 5 goes in 12 times. 4 goes in 15 times, right? 3 goes in 20 times. Is anyone scared yet? 2 goes in 30 times, and 1 goes in, woo, plus or minus. How many numbers do we have to test? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Good thing there's not another number here, or else it'd all be doubled. Yeah. So we actually have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 24 different ones to try. Now, do we have to try 24? No. Ideally, we try one and it works, and then we break it down, and all of a sudden it's a cubic, and we get to cross out some of these possible, because as soon as we break it down, the number gets smaller. And then maybe we find another one, break it down, it's a quadratic, and we don't even have to think about that anymore. So we could go ahead and... Can we plug in 1? Yesterday, a lot of you guys wanted to do synthetic right away. Is that bad? No. But can we plug in 1? I think so. So if we plug in 1 real quick, just trying to find somebody. We have 1 minus 3 plus 6 plus 2 minus 6. I don't think that's 0. We could try -1, but do you see how these numbers aren't very big and all of a sudden he's huge? I don't think 1's going to cut it at all. Okay, so we're canceling out 1. He's too small. We could try 2. Now, some of you are like, uh-oh, right away I'm tapping out of plugging in because I don't want to plug in numbers more than 1. But some of you are like, no, I can do that. All right, 2 to the 4th is going to be 4 and 4 is 16. 2 cubed is 8. 8 and 3 is 24. And 24. And 4. Oh, no, it's not working. I don't think 2 or -2. I don't think either one's going to work. Well, -2. What's going to happen with the -2? The negative's going to turn into a positive. Well, that's interesting. And then, oh, that's going to be a -4, though, isn't it? 2 times -2. Is that good or bad? 20, 40, 50, 60, 4, and 60. Oh, go team. Okay, so I didn't have to look too long. Some of you would have tapped out after the 1 and said, forget it, I'm doing synthetic. But would it have been bad if you had done synthetic with a +2? Well, yeah, your remainder wouldn't have been 0. But if you did synthetic with a -2, would that have been bad? Would have been great. Because if you went and did synthetic, there's a lot of numbers here, huh? -60. Oh, +10. What am I doing? Why is that a 6? I have no idea. Good question. What was I multiplying? I don't know. 10. 16. -32. -30. 60. Whew! I messed up too. I had to go back. Start finding zeros, or they could say finding a nasty polynomial. Do you get how I started? Plus or minus, look at all the factors of the last, which hopefully is a lot smaller than 60. And not on the test, I'm not giving you a big one. What's the biggest number? Probably a 12, maybe a 15. Probably not too much higher. And maybe there's even a GCF. Okay, coming back. Not of all of them, though. But do you see how I started, though? Like, I had a big, long list, and I said, let's start with the baby numbers, because I'm lazy. So are you. Okay, so start with the little numbers. Not lazy. Like, it's just being smart, right? It's way easier. And, hold on, the negative 30, can't I say, well, a factor of 30, so he's no longer an option? I mean, it'd be really nice if the number was a lot smaller than 30. I could cancel out more, but all right, well. So now I have, so far, negative 2, which is the factor. Are we okay with x plus 2 being the factor of that 0? Now I have an x squared. Tyler, I'm coming to you. Hold on. But technically, don't I need to? No. We could keep going. We could even try negative 2 again, because maybe he works again. Positive 2 definitely doesn't work, so no positives 2 out. But then I could try plus or minus 3, plus or minus 4, plus or minus 5, plus or minus 6, plus or minus 10. But has anyone realized that there was a clue all along that we've been ignoring? We'll be back to that in a second. Tyler. You can. Because once I've broken him down, his zeros, which are going to be shared with his zeros, but his zeros now are bound by this last term and this first term. So we can technically reevaluate our list. Does that make sense? And let's say that this number was something like 15. I could have canceled out the 60, the 30, and the 20. Not that we're necessarily going to be doing these anytime soon, but maybe it at least helps your brain a little bit. Bless you. Or maybe we had something like 12, and then you're like, well, 5 doesn't go into 12, 10 doesn't go into, so you could have maybe even canceled out other numbers too. So that's why it's nice to reevaluate your list. What's going on with the clue that maybe we could have used all along? I started going for it because I knew you guys would freak out with the 60, and I wanted to show you literally how we would approach if we hadn't been given any clues factoring this problem. But what's the clue say? Oh, they gave me an answer. All the answers? No. How many answers are there? 4. But they gave me one. 8. And it's complex. What do we know about complex zeros? They always come in plus or minus. So guess what? I know 2 zeros. If I know that 1 plus or minus 3i is, or are, since there's 2 of them, since I know these are zeros, I wonder if that could help me. You know how we took the negative 2 and we made a factor of it? We could technically do it with this guy too. Now you're not going to like it, sadly. Because all of a sudden, that's not a nice number. It's not an impossible number, but it's not a nice number. Technically, guys, these are 2 of our factors, so all we're doing is missing 2. And guess what? We just found 1 a second ago. So technically, we could have used that clue to help us. And now we know that x minus 2 is also a factor. If we could FOIL this out and do like a long division or synthetic division, maybe we could find this guy. It can't be, oh, did I not write it right? Sorry. It was negative 2, the 0, so the factor was x minus 2. Thanks, Joe. So they actually expected us to use this as a clue. Now some of you are like, I don't like that. I'm going to keep looking in this list and find my other nice 0. Okay, that's cool. I wouldn't mind that. But others of you were like, well, they gave it to me for a reason. Let's see what I can do. What we could do with the clues is we could FOIL, and we could get x squared. We could do outer, which is kind of gross, but it'd be negative 1 minus 3i times x. Inner would be negative 1 plus 3i times x. Last would be plus, oh, it's a difference of squares, huh? 1 minus 9i squared. And then we have our x plus 2, and we don't know that guy. We could do some simplifying stuff, and we would end up with x squared. What do we got? We have to distribute that x and the negative, so that'd be negative x plus 3ix, right? And distribute the x with the negative minus x minus 3ix. Oh, those cancel. Plus, wait, what's I squared? So that'd be 1 plus 9, which would be 10. Well, that's looking better. I still don't know who this guy is. Don't know who he is. So I end up with x squared minus 2x plus 10. And I'm just missing one more guy. How could I figure out that last guy? Yeah, we could do like a long division. We could divide that guy by this guy and figure out who's left and then try to find the last factor. I think that's what they originally expected you to do, was to say, hey, if 1 plus, then 1 minus is also, and then make some factors and went in. All right, let's divide. But did anybody try to keep going with the list and try to find another one? What goes in? 3. Positive 3? Okay, so some of you are like, wait a minute, I would have reached 3 really quickly. You would have tried negative 2 again. Lauren, hang in there, kiddo. I know. I would have reached 3 really quickly. Like Jason says it works, let's try it. Well, wait a minute, I have my numbers right there. Why not just try it with those guys? I don't even have to write anything else. We can build synthetics on top of synthetics. All right, here we go. That's not a life lesson, by the way. Bringing down the 1. 3 and 1 is 3. Negative 2, 6. Thank you. Which is 10. Thanks. I was like, 22 is not a good idea. And then we have 30, which is 0. Wait a minute. So we could have just kept going a little bit more, and what do you see? I would have had my x plus 2, my x minus 3, and my x squared minus 2x plus 10. That's that guy. Who ends... Oh, how could we have found those zeros or those factors on our own? Because, wait, sorry, what were the directions? If it was factor, we're done. Oh. Find the zeros. So I have to find the zeros of each of these guys. Those ones are easy, right? Because we have x equals negative 2, positive 3, and factor. Okay, x method. 10. Joe, I know, but I'm saying, what if people totally ignored that clue because they don't like it? Could you still get there? What is it? X equals negative b plus or minus square root b squared minus 4ac all over. You're just saying no. 2a. X equals 2 plus or minus the square root of negative 36 all over 2. Hey, isn't that 6i? X equals 2 plus or minus 6i all over 2. Ah! What can I do with the 2? X equals 1 plus or minus 3. Oh. One way is you could have taken their clue, you could have actually seen what it was as a polynomial, done long division, and you would have gotten the x plus 2 and the x minus 3 from the remainder, or I should say from the result of the long division. So one way was to figure out who this guy was and then divide, you'll find the rest. The other way is just go our normal route and hopefully the numbers are small, which they were. And then this guy, well, the quadratic formula got him, or, oh, they gave me a clue. If they gave me the plus 1, the minus 1's the other one, and 1, 2, 3, and 4, we're done. Okay, long story short. Can some of the problems in homework get a little weird? Yeah. But does still work and still apply to almost all of them. What do you do if it gives the directions, find all the factors of? You stop here. But what if it says find all the zeros of? Well, you keep going, right? These are the zeros. These are the factors. Now, can I just help you guys out a little bit in homework? Did anybody get to, that's not you guys. Hold on. Did anybody get to a weird set of problems that has like an A, B, C, and D and start talking about irrational numbers and rational numbers? And okay, let's go find that one. You might want to grab out your homework spirals because maybe this is where you stopped. I think it's in the 30s, right? Yeah.
The one in the 30s was easy, but like.
Oh, not 30s. Where are they? 50s?
That one had like steps, but it was easy. Like that one.
Yeah, 51. That's the one I was looking at. Doesn't mean there was nothing hard before that. Like, I'm not saying there was nothing hard. But in the 50s, it got weird. It didn't get weird for long. It was 51 to 54, and I think I just gave you 51. But can I show you guys what's going on in these? I'm going to steal the directions. I'm going to make up my own problem, because actually 52, 53, 54 is weird in another way, which is why I only gave you 51. But let me show you how these directions work, okay? You might want to just write this down in your notes as like a homework help. You might want to go ahead and let me do cancel real quick. I'm going to zoom in just a little bit more. You might actually want to go to your 51 and see if you can follow the process to solve. Okay, here we go. Yep. But you don't have to post any more pictures in Google Classroom. We're just going to be grading it on Monday. And section 2.6, which needs to come after the finish 2.5, is due on Tuesday. So. It was due in Google Classroom, submitted by this morning, but I said yesterday you only have to get halfway. Which, if you kept going, that's awesome. It wasn't posted in Google Classroom, but it was in class. I said you only have to get halfway. Let's figure out what's going on in 51, yeah? No problem. What if I was to give you something like, oh, I cannot make these up very well. Give me a second. Can you guys read the directions? A lot of you didn't even get here in homework if you truly took my halfway comment to heart. Or some of you got here and you're like, yep, nope, done. Irreducible over the rationals, meaning you can't go any more and still have rational numbers. And then the product of linear and quadratic that are irreducible over the reals, you can't go any more and keep it real. And then letter C says go all the way. Doesn't have to be real. Oh, it can be imaginary. So what if I was to give you something like, yeah, we could do this. This works. Okay, x to the 4th plus 13x squared minus 48. What if I was to give you x to the 4th minus 13x squared minus 48. Sorry, plus 13x squared minus 48. Does anyone notice anything special about this guy? Like, he is a quartic, but he's a special quartic. I can think of it as an ax squared plus bx plus c because there's only 3 terms, and the weird in-between ones are totally gone. The cubic one and the single one. So if we were to think of an x method, does anybody see anything that would work with 48 and 13? No? No? 6 goes in. Then what's that goes in? 1 goes in 48 times, 2 goes in 24 times, 3 goes in 16 times. Oh. Why say that this is? A says keep it rational. Well, wait, I can factor that. Some of you don't think you can, but you can. But is it a nice number? No, because it's a difference of squares. What's the square root of 3? It's an irrational number. So you can go farther, but it's irrational. This is as far as you can go and keep it rational. The next one says just keep it real. It can be gross. All right, fine. It's real, but it's gross. But that's as far as you can go keeping it real. What's the last one say? Go all the way. Wait, I can go more? If I don't have to keep it real, I can go more, because what's this guy got? It is plus or minus. Do you know what it's plus or minus? Can't we set them equal to 0? What happens if them equal to 0? X squared equals negative 16. X equals plus or minus 4. How do you go all the way? Go imaginary. Keep it rational. Well, that's as far as you can go and keep it nice numbers. Keep it real. Well, it's as far as you can go with gross real numbers. Keep it, well, don't keep it anything. Let's go. All right, fine. There's the real ones and there's the yucky imaginary ones. Dun, 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 dun. That's 51. Kind of. Otherwise, I think the directions are fairly self-explanatory, except, guys, what's your very last few homework problems written out? What are your very last? I want you guys to go ahead and cross out number 89 and cross out number 96. We're not even going to talk about it. It was never on the test anyway. Basically, these two tricks, Descartes' rule of signs and the upper bounds, are little tricks, little tests that would help. Jordan, you'd be interested in this. And the polynomials with lots of possible zeros. It helps you eliminate more. But am I going to give you one of those in the test anyway? So why stress about learning these tests if we don't need to? So cross off 89, cross off 96. They're cool little tests for really hard polynomials with tons and tons and tons of possible zeros. But we're not going to go there. So I'm going to even go in the notes and say, hey, there was some notes on Descartes. Nope. 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 Section 2.6. All right, we're just going to introduce this section today. We're just going to introduce this section today. Next week, because we have 2.6 and 2.7. Let's see, we're starting 2.6 today, finishing him on Monday. 2.7 we're doing on Tuesday. Should just be a one-dayer. Wednesday, a lot of you guys are taking the PSAT, so it's going to be a work day for any non-sophomores, non-juniors. Thursday, I believe, is the review. Because Wednesday is just a work day. I'm not going to review without the majority of the class. Thursday is the review, Friday is the test. Right before retreat. Is retreat next weekend? No. I felt like it was like 2 weeks away. Oh, I get it. That's what I was thinking. Yeah. And you have Wednesday as like a work day, like an extra day to come in if you have questions, et cetera, after the PSAT. Wednesday night might be Wednesday afternoon might be a really good day for math because you're not going to have most of your classes, my underclassmen. So hopefully you can focus on math. We'll see. We'll see. Rational, ratio, fraction. Oh, we're dealing with fractions, functions and fractions. And as soon as we have a fraction, we have to tell ourselves, uh-oh, fractions, denominators cannot be 0, right? Main problem, denominators can't be 0. And I think I've used this word this year, but we haven't really had to write it down. Discontinuities are what we like to call the x values that make the denominator. It's the big general term. So therefore, as you guys are writing, when I say x plus 2 can't be 0, And when I say x cannot equal -2, yes, there's interval notation for that, but long story short, it would be -2. -2 is called a discontinuity. You can put an accent in there, it's more fun. A discontinuity. A discontinuity. But it's not the only word for it. Because in any rational function, there are two different types of discontinuities. So we have to ask ourselves the question, is this a whole? Or is this a vertical asymptote? There are two different types of zeros in denominators. One's a whole, and one's a vertical asymptote. And so where we're ending today is writing down which is which. There are wholes that can happen in denominators, and there are vertical asymptotes that can happen in denominators. So let's talk about them. There are wholes that can happen in denominators, and there are vertical asymptotes that can happen in denominators. So how do we tell the difference without a graph? Because we are continually pushing for being able to deal with functions, recognize functions, analyze functions without a calculator. Having a natural understanding of how they move and behave and work without being stuck and bound to a calculator. Hopefully by the end of section 2.6, following some very specific steps, you guys are going to be able to do what I just did. Graphing this function, maybe not in your head, but by hand. And knowing the difference between zeros that make vertical asymptotes versus zeros that make wholes. Really quickly, does anybody see the one typo on this page? There's one typo. Does anybody find it? What should be my independent variable? Yeah. All right, cool kids. We'll talk about wholes and vertical asymptotes on Monday. Your goal, finish up section 2.5 homework and test corrections by the end of the day if they're not done yet. Bye, guys. Yeah. Are there any more? Yeah. The white pile, Priscilla. Bye, Joe. Happy Friday, happy nutrition, happy pajama day.
Is there brache bread today?
Yeah, he brought it in this morning, I think. You're going to get some.